Hello everyone, I am Khatter, Department of Computer Science and Engineering in ABES Engineering College. Today we will discuss the topic page replacement policies. It is an important topic of operating system. So the first thing is why we need page replacement policies. Then we will focus on the types of the policies and one numerical with some real life applications where we are using the page replacement policies. As the systems are growing up, they are focused on the higher degree of multi-programming. As we all are the end users, even we want to use the multiple applications on our laptops, on our mobile phones. But there are some limitations, like we have a limited amount of main memory, means the RAM. As we are increasing, for example, let's take an example. If there is a user and user wants to run the multiple applications on a system, say application A, B, C, D, E at the same time, then it is mandatory as per the nature of the operating system that all the applications or say the programs need to be loaded here in the main memory before the execution part. As I have shown here, the main memory architecture, they are the number of memory allocations which is already divided into the P1, P2 means the number of pages, the equal size of pages. Basically this is a chunk of the main memory. As application A, say taking the 3 pages, application B is there, it is randomly taking the 4 pages, application C is there which is taking 2 pages. Now what about the application number D and E? At the same time, user wants to execute A, B, C, D, E, all 5 applications, but we have a limited amount of main memory as shown here, P1 till P9. But A, B, C, all 3 applications are occupying all the memory. So how we are accommodating D and E for this? So in this case, we have to use the page replacement policies, and here the page replacement policies plays an important role. How page replacement policy works? Suppose in this application A, we are already using this data P1. After some time, this P1 page is already in use part. Then we will use P2, P3. So at this point, we can replace this P1 with some new page which is required by this D application. So in this manner, the page, this P1 got swept out to the secondary storage, and then a new page which is required by the application D, the next application, this new page will come here in place of P1. So this is the near about working. Let's take another layman's example. For example, in my pocket I have a space. I am putting one marker, marker 2, and I want to put one more marker, but there is no more space. In this, I am using the markers. I don't require any pen. But to use and to specify the things, I need a blue marker. So I will replace my pen with the marker. Now I have an entire space for these 3 markers. Again, if I need one more marker, a red marker, I am seeing here, okay, red marker is there. I need one more red marker, then this red marker. But I don't have much space. I will put one of the markers apart from red, suppose blue, and I will put this. So this is the same nature of the operating system memory management component which is using the page replacement algorithms. In the same manner, the pages are going to be replaced from the older pages and new pages are coming in as per the requirement of the applications. Now we will see the numerical part of the same. So in this manner, the page replacement algorithms works generally. But now we are talking about the types of policies. So in nature, there are many types of policies, say least recently used, first in, first out, most frequently used, least frequently used, optimal algorithm, second chance algorithm. But the more common are only 3. First is LRU, second is first in, first out, generally we represent it as a FIFO, third is optimal. So these are the 3 main algorithms which are known as a page replacement algorithms or page replacement policies. Let's have a look to a numerical part of the same. I have taken a page reference string, say as per the application's requirement, the number of pages, the occurrence of pages are written here, and we have to adjust those pages as per the requirement in a memory location. A memory location, in a previous example, in a previous diagram, I have taken 9 pages. Right now I am taking a buffer size of 3. Buffer means as my pocket contains a maximum at 3 pens, as in the memory I have seen the 9 spaces are there. So here I am taking a buffer size of 3. 1, 2, 3 means at max the 3 pages can accommodate at a time. Initially the memory is free, or we can say when a new page arrives in a memory, it is considered as a page fault. Means we are writing something in a main memory, so this is considered as a page fault. Initially the buffer is empty. Buffer is like this. So 3 spaces are there, 1, 2, 3. Now the first page, this means the page number 1 is calling out by a program and the main memory is right now empty. So 1 will come here. Again a request of page number 2 by some other application or a same application. So 1 is already there. Page number 2 will come here at the second location. Now the third occurrence is page number 3. So 1, 2 were already there in the buffer. 3. So 3 is there. Now again the request by the same application or some other application by page number 2. So here we are seeing the page number 2 is already available, as I have shown that in my pocket the red pen is already there. So I don't require the second red pen. So here the page number 2 is already there, means this is page fault, this is page fault, this is page fault. But here page number 2 is already there in a buffer, so no page fault is there, means the memory will remain same. Next occurrence is of page number 1. Page number 1 we are seeing here, the page number 1 is already there, means again no page fault. Next is page number 5. A page number 5 we are seeing here, in the buffer we have 3 spaces which is already accommodated by page number 1, 2 and 3, and page number 5 is not there. Now we have to replace the page number 5. So here we have to use those algorithms, means might be we are applying the LRU, least recently used, FIFO means the first in first out, and the optimal policy. So okay, we will take an example of the LRU, means the least recently used. So here we are seeing the page which is least recently used, means at this point, if I am making a margin here, at this point currently we were using page number 1 and page number 2. So we can't remove these old pages from the buffer for this new page. So we can't remove 1, we can't remove 2. So the rest one is 3. So when we free this space, only then the page number 5 will come here on this place. So we will swap out this page number 3 and call out page number 5 here. Now this is considered as a page fault because a new page is coming to the main memory. Next, again the occurrences of 2. If we are seeing here the occurrence of 2, page number 2 is already there in the memory. Next is, as per the page reference string, the page number is 1, which is already there in the memory. Now the page number 6 is here. Page number 6, which is not in the buffer, we will check the least recently used page. Among these 3, the least recently used page is page number 5. Then we will change 1, 2, this 5 to 6. So page number 5 goes to swap out and swap in is page number 6. Again this is considered as a page fault. Check for the same string. The next occurrence is of page number 2, which is already present there, page number 5. Now 5 is not present here. Now check, 2 and 6 are currently used. So we'll remove 3, the third page means 1. So here 5, 2, 6. The next occurrence is of page number 6, which is already there. So in this manner we are seeing here. So this is a general approach of least recently used. Now we will take another example here. I am making a margin. For the second approach is our first in first out. This is the simplest approach which we are using here. This approach is to take the pages in as per their occurrences. So initially my buffer is free, which contains of the 3 spaces, 1, 2, 3. Now the occurrence of the first page is page number 1. I am accommodating here at the first location, page number 2, second location. Both are the page faults because we are writing a new pages in the memory. Page number 3, 1, 2, 3. This is again a page fault. Now page number 2 which is already present in the buffer, so there is no page fault. Here page number 1 already present, page number 5, oh, now again it's a new page. We are seeing here 1, 2, 3 are the number of the pages which are there in the buffer, but here we have to accommodate a space for the page number 5. As per the policy FIFO, first in first out, we are seeing the buffer which page comes first. The page which is there in the memory from the longest time will replace first. Here we are seeing the 1, 1, 1. 1 is repeating again and again, means the first page was 1. So now we will remove this page, means swap out page is 1 and the swap in page is 5 as per the requirement. So we are removing here, I am writing 5, 2 and 3. This is one page fault. Next, the next page is 2, which is already present here, means no page fault. Next page is 1. Now 1 is not in our buffer, so we have to accommodate a space for 1. Now check which page is in the for the longest time. 2, 2, 2. 2 is occurring again and again. So we will replace 2 as 1 and 3 is already there. So now this is a new page 1. Again check the next value 6. Here the 6 is a new page which is not present in the buffer. So again we will check the same condition, means the 3 is the page which is residing here in the memory from the longest time. So we will replace 3 by 6. So 6 comes here. Now 2, again we have to check and remove the page, old page. This is based on the policy FIFO, first in first out. So we are seeing here among these 3 pages which page was there from the longest time, which is the page number 5. So we will remove 5. The next is page number 5. So now 5 will check which page is there for the longest time. So page number 1 is there. So we will replace 1 by 5. All are the page faults. 6 is already there in the list, means there is no page fault. So if I am comparing both the algorithms LRU and FIFO, I am seeing here the LRU consisting of 1, 2, 3, 4, 5, 6. 6 page faults are there in LRU, and in FIFO, the first in first out page replacement algorithm, count of page faults are 1, 2, 3, 4, 5, 6, 7, 8. 8 page faults are there and 6 in LRU. These both algorithms are practical in nature, but the third algorithm is the efficient algorithm, but it is impractical in nature. Let's take a look to this algorithm. As we know that the size of our buffer is 3 and the occurrence of the pages, the reference string is given here. The first page is page number 1, then page number 2 and page number 3. All 3 pages come to the memory with a page fault and shown as 1, 2, page fault 1, 2, 3. Now the upcoming pages are page number 2, which is already there in the memory. Next the page number 1, which is already there in the memory, so there is no page fault. The memory space will remain same. Now the problems comes with the page number 5, which is not in the memory. Now we have to apply here the optimal page replacement algorithm. Page number 5. Now what's the case of optimal? Optimal will check which page we are going to be used next. Say I know that I have to evaluate the copy, so I need a pen, I can't use the marker. So after seeing the future references, I can't remove pen from my pocket. So this is the same concept by the optimal. We are seeing here the 5 is a call and the upcoming pages are page number 2 and page number 1. So in these values, in these pages from the buffer, we can't remove 1 and 2. So this is our call. This is the policy of optimal page replacement. So here we will remove page number 3 from the buffer as 1, 2 we are using the next in the future, and the 3 might be we will use this 3 page after some time, but currently we are in the space of 3 we are using these 2 pages. So obviously we have to remove the third page, which is page number 3. So 5 will come here on the place of 3. This is the concept of optimal. Okay, let's see another example. 2 is there already in the memory. 1 is already in the memory, so no page fault. Now 6. In case of 6, again we are saying the 6 is not present here in the memory, so we will remove the page which we are not using for the long time in the future. So the next pages are page number 2 and page number 5. So we are checking here, page number 2 and page number 5 are there. So page number 1 we are not using in the future, so we will remove this page and put a new page, page number 6 here as 6, 2, 5. So now this is a page fault. As per the reference string, the upcoming pages are page number 2, which is already there in the buffer, page number 5, which is already there in the buffer, and the last page number 6, which is already there in the buffer. Now we are saying here the number of page faults, the number of count 1, 2, 3, 4, 5. Only 5 page faults occurred here in the algorithm of optimal. But we are seeing a scenario, we are checking the upcoming pages, means the page number 2 and page number 1. Is it really possible that I know or the processes know the upcoming requirement? Means yes, okay, I need this thing, I need this thing. So this is the drawback of this algorithm. We can't predict the upcoming occurrence of the pages. So among these 3 algorithms, this optimal algorithm is impractical in nature. This is only be used when we know the upcoming pages. We can predict this. Only these pages can become and another page will not come. And LRU is the best algorithm, means in the 90% operating systems, in our, might be it's our Android phone, we will also see the example of this. We are using the least recently used algorithm. And FIFO is the commonly used algorithm. This is the simplest algorithm for this. Let's have a look of this LRU. Is it really applicable or not? So as we have seen in the comparison of these 3 policies, the LRU is best among all because optimal algorithm is impractical in nature. I have a Samsung smartphone. In this, there is an option of active applications. If I am going there, we can see that in the RAM part, you are seeing here the least recently used algorithm is used by the Android. In the same manner, the Windows, Linux, all are using the least recently used page replacement policies. Okay, thank you.